Alright, so now applications of exponential growth and decay kind of mixed together, similar to what you'll see in the homework and the quizzes. Just so you know, the homework does word things a little differently, so I made sure to include some here with sort of the wording that they use. Alright, so the first example, suppose that we have an isotope known as carbon-14. It's radioactive, it decays stable. Again, this is how you do tests. Again, carbon-14 is how they test a lot of things, because again, we know the decay rate, right? You absorb carbon-14 until you die, and then it starts to decay. You have a certain amount when you die. Alright, suppose that the half-life of carbon-14 is 5,770 years. Assume an organic sample is 15,000 years old. How many half-lives will have gone by in 15,000 years? Round your answer to it. So this is just asking you for that H, right? So the years into the future divided by our half-life. And so in this case, it would be 15,000 years went by, and the half-life was 5770. And so it comes out to 2.59965, rounding your answer to 2 decimal places, meaning this 9 rounds this up to 10, and so it comes out to 2.60 is how many doubling times. So that's what you would put when it asked you for how many doubling periods is. 2.6, and if we're rounding 2 decimal places, you include the 0. Alright, suppose the balance of an investment is increasing according to the rule. Next year's balance, 1.84 times the current balance. If the original value of your investment was 600, find the formula that gives the balance in T years. Alright, so this is just asking you for the formula. So B is my future balance, that's B. Current balance, well, that's 6. And so we get 1 plus R is the 1.84, because that's what we're multiplying by. The present value, or B naught, is 600, and so this is 600 times, and I believe they do use the X symbol, 1.84 raised to the T. So just be aware in the homework that's how it is. If I were writing it out, this is often how I'll write it out. It goes to mean the same thing. Again, they like to use the X symbol when it's, so just be aware this is how the homework will ask you for it. Or usually it gives it to you in terms of a multiple choice, I believe, in this case. Alright, but that's what they're talking about here. So again, this is how much we multiply by, and so that's the percent increase. So it's a pretty big percent increase. It's an 84% increase. The 1 represents the starting balance, and this is how much we grow by. Alright, so that's the formula we're looking for. Determine if the following situation is modeled by a linear function or by an exponential function. Bob's salary grows by 1,000 each year. Every year we gain 1,000. Right? No more, no less. And so this is a constant growth rate. A constant growth rate is a linear model. And so you would get a line in this case where our slope is 1,000. Every year we add 1,000 to the account. It's not 1,000, it's not any more than that, right? It's not a percent growth. We're not growing by a certain percentage. Every year it's a single thousand, alright? So it's linear because it's constant. My second example then, based on the fact that I did 2 of these, this is probably the exponential growth case, but you should understand why it's the exponential growth case. Suppose that the world population in 2016 was estimated to be 7.4 billion people, and it's increasing at about 1.1% per year. Assume the percentage growth rate remains constant to the year 2030. Would it be modeled by a linear or exponential? This is an exponential case because it's growing at a percent of its size. Meaning, in 2016, we used the 7.4 and multiply by the 0.011. But whatever that number comes out to be, it would be bigger than 7.4, right? We'd add that to the 7.4, and then whatever that number would be, we'd multiply by that in the next year. So it's exponential growth when we're growing by a certain percentage of its size. So this is a percentage rate. A percent growth rate, which means exponential growth. All right, number 5. For traffic, all right, suppose traffic flows on a highway. Is the average? So with the traffic flow on a highway, the headway is the average time between a vehicle on a 4-lane highway. The probability p as a decimal that the headway is at least t seconds when there are 500 vehicles per hour traveling one way is given by the following equation. I didn't read that very well. Under the circumstances, what's the probability the headway is at least 10 seconds? Round your answer to one decimal place. So again, I believe I got this out of the book. All right, the headway, the average time between, so the headway would be the average time between vehicles. So how much time there is between one vehicle and the next vehicle. All right, so the traffic flow. We want to know what's the probability, because the formula gives us the probability as a decimal. What's the probability the headway is at least 10 seconds? So 10 seconds is the time. All right, and so we're looking for the probability, which is 10. So 10 is what we're plugging in. So 10 goes into the time. So this is just using, what's weird about this one is, again, I believe it was just weirded. Sometimes they word things just a little differently, and so what you have to sort of understand, what am I given? Well, I'm given the seconds between each vehicle in vehicles per hour, and that's given to me by that equation. And so we're just going to plug into that equation the time given. So we just take 8.7 raised to the 10, and so it comes out 0.2484, so rounding 2 decimal places, 0.25. So that would be the probability given as a decimal. Alright, with number 6. With new technology, alright, we have different types of business revenues. It's common for growth to be exponential when it starts out, alright? A lot of times businesses will boom, right? And then it levels off eventually, but in the beginning, it does have exponential growth. An example of the growth of the example is the internet domain host. Alright, one model for the number of domain hosts grew according to the following rule. So next year's number equals 10.4 times the current number. Alright, the number of domain hosts in 1995 was 8.6 million. Find the exponential formula that gives the number of hosts. So what this is telling you, alright, this is the future value, this is the current value, this is the r plus 1. So it's growing pretty fast. And so when you write this out, when you want the formula that gives the number of hosts, I'm going to let H be the number of hosts. I'm just going to write a hotel for some reason. T is years. And so the number of years is that 10.4. I forgot my current number. So that's my initial value is 8.6 million. Alright, so it's the initial value, 8.6, times our r plus 1, which is the 10.4 raised to the t. In the homework, oftentimes this shows up, just so you're aware, 8.6 times, with the x, kind of an x symbol, 10.4 raised to the t. So just so you're aware of, that's sort of what terminology they use, alright? So that's the symbols that they use. And this would be the answer you're looking for. So initial value times 10.4 raised to the t, the number of years. Alright, physical process. Alright, typical way of cleaning the contaminant in water is the water is cleansed at constant rates. The mixtures run out at the same rate. Suppose the initial pounds of a contaminant of a large tank. Suppose initially there are 100 pounds of a contaminant in a large tank of water. Assume the cleaning method described above removes 30% of the contaminant contaminant. I can't read today. The contaminant each hour. Find the exponential function that gives the number of pounds of contaminant left in the tank after T hours. Alright, so I'm going to let C be the amount of contaminant. T is my time. My initial amount was 100 pounds. My R is 30%, so if I write that as a decimal, that's 0.3. And so this time I actually have to find, right, my initial amount, 1 plus R raised to the T. And so my initial amount is 100, 1 plus 0.3 raised to the T. Do simplify that. If you type it into the formula, they do want it simplified. Again, this is how I typically write it, but if you're typing it into the WebAssign, it'll be 100 times the 1.03 raised to the T. They use this X as the time symbol, so just so you're aware of that on the homework. Alright, the last example, I believe. You owe $550 on your credit card. For every month that you fail to make a payment, your balance increases by 3%. Alright, find the formula for the balance owed after T months with no payments. Alright. So the initial amount is 550. T is in time, in year. Oh no, months. T is in months. R is 3%, but write that as a decimal. That's 0.03, right? You take the 3%, divide by 100. That gives you your 0.03. And so our balance is our initial amount times 1 plus R raised to the T. So it's 550 times 1 plus 0.3. So make sure you're careful there, 0.3. And then add it up. So 1.03 raised to the time. Again, if this is on the WebAssign, this is how you'll input it. Alright, so just make sure you're careful on the WebAssign. This is on the WebAssign. And then a lot of times you're asked to use it, but it's usually the hardest part is getting the equation. Once you have the equation, it's just to plug it into your calculator and go. Alright, so that finishes up exponential growth and exponential decay.